Lesson 6-1 is on solving systems by graphing. So the objectives of this lesson are to identify solutions of linear equations in two variables, so you have an x and a y, and to solve systems of linear equations in two variables by graphing. So you're going to have to learn what a systems of linear equations is and what is truly a solution of a system of linear equations. So you start with one equation. Choose an ordered pair that's a solution of y equals x plus 1. Well, if I said x was 0, then 0 plus 1 is 1, so y would equal 1. If I said x was 1, then 1 plus 1 is 2. If I said x was 2, then 2 plus 1 is 3. Now I could do this for a bunch of ordered pairs. There's an infinite amount of ordered pairs that would work with this. So which of the ordered pairs is also a solution of y equals 5 minus x? Well, if I let x equal 0, then 5 minus 0 is 5. If I let x equals 1, then 5 minus 1 is 4. If x is 2, then 5 minus 2 is 3. So there's my match. 2, 3 is a solution of y equals x plus 1, and 2, 3 is a solution of y equals 5 minus x. So there's only going to be one ordered pair that's going to be a solution to both of those equations. And this lesson is going to show a method for finding that pair, because the method I used was just trial and error, and I got lucky to find the 2, 3. So we need a much more efficient method for finding that solution 2, 3. So what is a system of linear equations? It's a set of two or more linear equations containing two or more variables. So the problem we just did, y equals x plus 1 and y equals 5 minus x, is a system of linear equations. So a solution of a system of linear equations with two variables is an ordered pair that satisfies each equation in the system. So that ordered pair 2, 3 was the solution to that system of linear equations. So if an ordered pair is a solution, it will make both equations true. So in example 1a, you're to identify systems of solutions. So tell whether the ordered pair is a solution of the given system. So 5, 2 means x is 5 and y is 2, because in an ordered pair it's always x comma y. So if this is a solution to the system 2/5 x minus y equals 0 and 3x minus y equals 13, then I should be able to plug this into both equations and get a true statement each time. So I would do 2/5 times x, which is 5, minus y, which is 2, and I should get 0. Well, 2/5 times 5, 5 divided by 5 is 1. So then I end up with 2 minus 2 equals 0, which is true. 0 does equal 0. So I know that 5, 2 is a solution to the first equation. But for it to be a solution to the system, it also has to be a solution to the second equation. So then I'm going to do 3 times 5 minus y, which is 2, and see if I get 13. Well, 3 times 5 is 15. 15 minus 2 is 13. 15 minus 2 is 13. So that is definitely a solution. So yes, it is a solution. So the ordered pair 5, 2 makes both equations true. So 5, 2 is the solution of the system. If an ordered pair doesn't satisfy the first equation in the system, then you don't even have to check the second equation. Because for an ordered pair to be a solution to a system, it has to work in both equations or it's not a solution. So pause the video and see if you can do this question on your own. So tell whether the ordered pair is the solution of the given system. So in this case, I know that x is holding the place for a -2 and y is holding the place for a +2. So I'm going to plug it into x plus 3y equals 4. So the x gets replaced with a -2 plus 3 times y, which is +2, equals 4. So you're asking yourself, is -2 plus 6 going to be 4? So does 4 equal 4? Yes. So you know -2, 2 is a point on the line x plus 3y equals 4. So then you try it in the next one. Now you got to remember that -x, there's really a -1 in front of that x. So you got to be careful about those negative signs. So you're really doing -1 times x, which is -2, plus y, which is 2, and asking yourself, does it come out 2? So negative 1 times negative 2 is a positive 2. Is 2 plus 2 equal to 2? Well, 4 is not equal to 2. So is that ordered pair negative 2, 2 a solution to the system? No. So the ordered pair negative 2, 2 made one equation true, but not the other. So if it doesn't work in both of them, then the ordered pair negative 2, 2 is not a solution to the system. All solutions of a linear equation are on the graph of the line. So if you wanted to find a solution to a system of linear equations, you have to have a point that each line would have in common. So that point's got to be on each line. So in other words, you need their point of intersection, so where the two lines are going to cross. So if my system of equations is y equals 2x minus 1 and y equals the opposite of x plus 5, then I would need to figure out what the ordered pair is that works in both equations. Well, the one that happens to work in both of them is 2, 3, because 3 is equal to 2 times 2 minus 1. So 3 is equal to 4 minus 1, so 3 equals 3. So I know the point 2, 3 works in y equals 2x minus 1. So if I went over 2 and up 3, I know that point is on that blue line. Well, it also works in the second equation, because 3 is equal to the opposite of x, or negative 1 times x. Negative 1 times 2 is negative 2 plus 5, so 3 is equal to 3. So I also know the point 2, 3 is on the red line. Okay, so since 2, 3 worked in both equations, that's where the two lines intersect. So that's how I know that the ordered pair 2, 3 is a solution to the system, because it's where the two lines intersect. Sometimes it's difficult to tell exactly where the lines cross when you solve by graphing. It's good to confirm your answers by substituting it into both equations. So when you graph, you have to remember how to graph by the slope and the y-intercept. So this is a little bit of a review. So the equation has to be in slope-intercept form, which is y equals mx plus b. And you have to remember that m stands for the slope, which is rise over run. So you count vertically, and then you count horizontally from the y-intercept. And b is the y-intercept, and this is the point that's on the y-axis. So if I was going to graph x plus 2y equals 1, first thing I would do is I would move the x to the other side. So I would subtract x on each side. So that's why you're left with 2y equals, and then putting the x first, be negative x, then plus 1. And then I have to get rid of the multiplying by 2, so I divide everything by 2. And that's how I end up with y equals, and remember there's a negative 1 in front of that x, so that's where you're getting the negative 1/2 x plus 1/2. So if I was going to graph that, I would put a point on the y-axis at 1/2, and then I would count down 1 and right 2 to make sure that the line had a negative slope. For 2x plus y equals 5, to get the y by itself, I would subtract 2x on each side. So then that would get me down to y equals, and then I like the x to be first, so these two have to trade places, so you got to remember to carry the sign. So negative 2x plus 5. So if I was going to graph that one, I would put a point on the y-axis at 5 and count down 2 and right 1 so that I would have a negative slope. So what I know about these two lines is they have different slopes. The first line has a slope of negative 1/2. The second line has a slope of negative 2. Anytime two lines have different slopes, eventually the lines are going to cross each other. So there is going to be an intersection point. So for the first line, we said we had to put, so we have to put a point on the y-axis at 1/2. And then from that point, we have to count for the slope negative 1/2. So I would count down 1 and right 2. And then you really should use a ruler when you connect these. So there's my line, x plus 2y equals 1. Then to graph the second equation, my y-intercept was 5. So I put a point on the vertical axis of 5. And I count for my slope of negative 2 over 1. So I count down 2, and I count right 1. That gives me a negative slope. And then I figure out, where did these two lines cross? So it looks like they're crossing at 3, -1. But to make sure that's right, you should really plug that back into each equation to see if it works. So if my solution is truly 3, -1, I should be able to plug a 3 in for the x and a -1 in for the y, and it should work. So is 3 minus 2 equal to 1? Yes. So I know it's a point on the first line. Is 2 times 3 minus 1 going to be 5? So 6 minus 1, 5? Yes, it is. So I know that is the solution to the system of equations. That is definitely where the two lines intersect. Example 2b, you're going to solve the system by graphing. You're going to check your answer. So the system is y equals x minus 6 and y plus 1/3 x equals -1. Well, the first thing you want to do is you want to get both of them in slope-intercept form. So the second equation is not in y equals mx plus b form. So the first thing you're going to do is get the y by itself by subtracting 1/3 x on each side. So then you know that y equals a -1/3 x minus 1. So if I go to graph these, okay, this one happens to work much better using a calculator because the answer to this one is not going to come out to be a nice, neat whole number. So what you notice here is that when I graph each of these two lines, the intersection point is 3.75, so 3 3/4, and a -2.25, which is a -2 1/4. If you try to do that by hand, it would be so hard to get it perfect because you have to use a ruler when you do these. That's the best you can do, and then you're going to end up having to guess what those fractions are. So that's why you should use a calculator. So here's what it looks like on the TI Nspire. So you can see the labels for each one of the graphs, and you can see that the point of intersection is 3.75, -2.25. So now I want to go through and show you how to use the calculator to get the point of intersection. So the first thing you want to do is either open up a document or the Scratchpad. So I'm just going to open up the Scratchpad. Click Scratchpad twice so that you get to the graphs. And then you're going to graph your two equations. So the first one was x minus 6. So x minus 6, hit enter. So there's your first equation. The second equation, to get that equation bar back up, you can hit the tab key. And I had a fraction, so I'm going to do a control divide. And then I'm going to type in a -1/3. Tab out of the fraction. And then type in x, and then it was -1. So there's my second equation. And of course, I can move these just by grabbing them to get them out of the way. And then I need the intersection point. So then I go to Menu, and I want to go to Analyze Graph. And under Analyze Graph, number 4 says Intersection. Then you get this vertical line, and it'll say Lower Bound. So you want to be on the left-hand side of where the two lines intersect. Click. Then it'll say upper bound, so you want to be on the right-hand side of that intersection point. Click or hit enter. And then you can see the intersection is 3.75, -2.25. Out example 3. Video Club A charges $10 for membership and $3 per movie rental. And Video Club B charges $15 for membership and $2 per movie rental. For how many movie rentals will the cost be the same at both video clubs? What is that cost? So when you go through solving a word problem, the first thing you have to do is understand the problem. So the answer will be the number of movies rented for which the cost will be the same at both clubs. And then you always have to list like what your important information is. Well, you know the rental price at Club A was $3 and at Club B was $2. You know the membership cost for Club A was $10 and at Club B was $15. So you make a plan to solve the question. So you write a system of equations. One equation to represent the cost of Club A and one for Club B. So you got to pick your variables. So let x be the number of movies rented, because that's your independent variable, And why be the total cost? Because the total cost depends on the number of movies you rented. So your total cost is your dependent variable. So you know that total cost is going to be the price for each rental plus your membership fee. So when you write your system of equations, your first one for Club A, your total cost is Y, and that's going to be equal to the price for each rental, which was $3, but you don't know how many you're renting, so that's times X, plus your membership fee, which was $10. For Club B, total cost is Y, and that's equal to the cost for each rental, which was $2, times how many you're renting, which is the X, plus your membership fee of $15. Then what you're going to do is you're going to graph these two equations and see where they intersect. So when you graph them, this is what you get. Okay? So the lines appear to intersect at $5.25. So the cost will be the same for 5 rentals, and the total cost will be $25. But what's this going to look like when I try to do it on my calculator or by hand? Okay, first thing you do is open up a graphs page, and you're going to do 3x plus 10. Okay, so first I do 3x plus 10. Okay, so first I type in 3x plus 10. Then to get the equation bar back up, you hit the tab key and type in your 2x plus 15. And then what I notice is I can't see the intersection point. So I can't see where they cross each other. So you go to your menu key, go to Window and Zoom, and then you want it to fit. So then you have to go down and choose letter A. Now I can see where they cross. I need to move these labels so I can see which label goes with what line. So of course F2 of X had a y-intercept of 15. So that would be this line. And 3x plus 10 at a y-intercept of 10. So that's the bottom line. So then I need to know what this intersection point is. So you go back to Menu, you choose Analyze Graph, and you want the intersection. Then you move your vertical bar on the left side of the intersection point, click, then move it to the right side of the intersection point, and you can see they cross at 525. So if we come back to look at the nice, neat graph that's all labeled, you can see that 5 movies, which was the x-axis, is a cost of $25. And then you should always check your work, especially on these graphing problems, when you don't use a calculator. So check 525 using both equations. So for the number of movie rentals for Club A to reach $25, you would have to do 3 times 5 plus 10, which is 15 plus 10, which is $25. The number of movie rentals for Club B to reach $25 is 2 times 5 plus 15, or 10 plus 15 is 25. So you know you've got it.